Ionic bonding, just a quick recap. I would memorize these definitions because the words have been very carefully chosen. So ionic bond is electrostatic attraction between oppositely charged ions. There's two types of ions, anions are negative, cations is a big T is positive. Just to recap on the videos where we did ionic, covalent and metallic bonding, they're the three strong types of bonds. I wouldn't say one is stronger than the other, they overlap a little bit. If you look up a table, you'll find that some metallic bonds are stronger than some covalent bonds, some are stronger than some ionic bonds. So there's no single category there, but intermolecular forces are always weaker. There are some hydrogen bonds that are stronger than some intramolecular. So these three, ionic, covalent and metallic bonds, are the inside the molecule, and you'll eventually get to intermolecular forces, attraction between different molecules. Okay, so this actually here is not a molecule, but that's fine. We're still going to call these intramolecular forces. And so what you need to also remember is that just in the diagram, as we saw above here, just quickly, that what we have here is you just have basically positive attracted to negative. So you've got these metallic bonds, the electrons are free to move. Ionic bonds is the pull of the electronegativity difference is greater than 1.8. So most of the electrons are over here. Anywhere in between there, halfway in between is a covalent bond. Somewhere in between 0.4 and 1.8 as the electronegativity difference between the two atoms is called a polar covalent bond. So that's just an overall of all of the types of bonding. Now specifically ionic bonding, what you have here is you have this thing called a lattice. Now covalent and metallic lattices you also have, but we're going to talk about ionic lattices in this one. You can see here if you go up here, so that could be the y-axis, the x-axis and the z-axis, you can see that each single sodium is surrounded by 6 chlorines, and that's repeated. And so that makes this particular molecule quite strong to have a high melting and boiling point, as you will see also with metallic substances and covalent substances if they're in a lattice, not simple covalent molecules. And so that is why that is occurring. Because they're locked in place, and their electrons and their charge is very closely linked to the anion and the cation, the electrons are not free to move, and so you have to melt this or dissolve it for the charge to be carried. So it'll only conduct electricity if it's molten or in solution. And lastly, volatility. It has a very low volatility, as you'd expect, which is very much linked to molten boiling points. So how easily it just goes into a gas. And so last one is brittle. Because it's locked in this structure, if you just tap it a little bit, then all of a sudden, instead of everything being attracted to each other, everything repels each other. And so it'll instantly crack and split in two. And so that's why these things are particularly brittle. So moving on, the next slides will cover covalent and metallic.